Welcome to the Deep Dive, your shortcut to getting up to speed on complex topics. Today we're diving into a really critical and, honestly, quite expensive environmental challenge, especially for Europe: biological invasions. Where species end up outside their native homes, often with pretty damaging results. We're looking closely at a specific study here. It's called Policies Slow Biological Invasions in Europe, but Legacies Still Matter. The lead author is Canelles, published with colleagues in One Earth.
And it's a crucial piece of work because, well, the stakes are just massive. Biological invasions, they're a top driver of biodiversity loss worldwide. They cost economies billions, impact our well-being, our activities. It's huge. And we know the numbers of these established alien species, EAS, and the really problematic invasive alien species, IAS, they're just climbing fast. So the big question is, are the things we're doing to stop them actually making a difference?
Yeah, that's the million-dollar question, isn't it? We've poured resources into agreements, regulations for decades. But if the numbers keep going up, how do you even prove your policies are working? So what exactly did this study try to measure about European policies?
Well, they really wanted to pin down whether all those efforts in international agreements, national rules focused on prevention, on management, whether they actually cut down the number of invasions in Europe. They looked across 28 countries, the EU members and the UK, and they compared essentially two main things: the raw number of established alien species, the EAS, but also, and this is key, the changes in the invasion rate over time. And they mapped this against the policies each country had put in place.
Okay, 28 countries, different policies, decades of data. The learner must be thinking, how on earth did they pull that off? What kind of data are we talking about here?
Yeah, the scope is impressive. Geographically, like I said, 28 European nations. And taxonomically, they covered a lot of ground: vascular plants, ants, birds, mammals, spiders, even amphibians and reptiles. Altogether, it was something like 6,667 species they tracked. Gives you a sense of the scale. And to measure the policy side, they developed this scoring system. They looked at 58 different criteria for national IAS policies, mostly stuff from the 90s and 2000s, so kind of before the big EU-wide regulation came in later. They scored how well each country covered these criteria from 0 to 3 and crunched that into a single total management score.
Right, okay, and this is where it gets really interesting, methodologically speaking. Because just counting species doesn't tell you if a policy from, say, 1998 is working now, especially with invasions that might have started centuries ago. I saw they use this term directional EAS. What does that mean exactly?
Good question. It's about tracking the spread. So instead of just saying Germany has X alien species, they looked at species moving from a source country, let's call it country I, to a recipient country, country J. This way you capture the direction and, crucially, the timing. The species has to be known in country I before it pops up in country J.
Ah, I see. So you're tracking the actual movement, the pathway, not just the final tally in each place. And to sort out the history versus the recent policy effects, they use 3 different models, right? That seems critical.
Yeah, absolutely crucial. So model 1, they called it the total invasions model. This one looked at basically all potential directional movements across their entire data set, which went way back, like 5,000 BCE up to 2020, the whole historical sweep. Then Model 2, the recent invasions model, this narrowed the focus. It only looked at those directional EAS that were newly recorded after 1995. They picked 95 because, well, that's around when a lot of these biodiversity agreements and policies really started kicking off. And then the real game changer, Model 3, the rate change model. This also used the post-1995 data, and here's the clever bit, it included the number of EAS that were already recorded before 1995 as a factor in the analysis. So by controlling for that historical load, that baggage of past invasions, they could actually measure the proportional change in the rate of new invasions. That makes so much sense. It's like trying to measure how well your air conditioner is cooling the room, right? You don't just look at the current temperature, you look at how fast the temperature is dropping, considering how hot it was to begin with. Okay, so the moment of truth. What did these models reveal about policy effectiveness in Europe?
Well, this is where it gets fascinating, and maybe a bit counterintuitive at first. In those first 2 models, total invasions and recent invasions, looking at the absolute numbers, that total management score, it showed no significant link to the number of directional EAS.
Wow, hang on. So if you just look at the totals, even the recent totals, it looks like the policies didn't do anything. Or at least you can't prove they did.
Exactly. Based on those numbers alone, you'd struggle to say the policies worked. The effect just wasn't visible. But then they ran the rate change model, the one that accounts for the historical context. And there they found a significant inverse relationship, meaning Countries with higher total management scores, more policy effort, actually had a lower number of new EAS coming in once you factored out the pre-1995 baseline. So the policies are working, but their effect is subtle. It's reducing the rate of new arrivals, not magically erasing the past accumulation. This sounds like a classic case of Simpson's paradox, doesn't it? Where the overall trend masks what's happening in the subgroups.
Precisely. Simpson's paradox is exactly the right analogy. You see one trend when you look at the big aggregated picture, like the total number of invasions just keeps going up. But when you slice the data differently, accounting for that crucial variable in this case, the historical invasion load, the underlying trend reverses. Policies are having a protective effect, but it was being swamped by the sheer weight of past invasions and other drivers. And that's really the core novelty of this study. You can only see the policy effect when you look at the change in rates, not the absolute numbers. It's about bending the curve.
Okay, but if the effect is that subtle, if it's hidden in the rate change, how do policymakers make the case for continued funding? How do you convince people these expensive measures are worth it when the overall invasion numbers might still be climbing?
That's the practical challenge, isn't it? And I think that's where this paper is so valuable. It provides the quantitative evidence. It says, look, these sustained efforts do make a measurable difference to the rate. Without this kind of rate change analysis, yeah, it would be really hard to justify the investment based just on the total species counts. This kind of evidence is vital if we're serious about meeting global targets like the Kunming-Montreal goals, aiming to cut introduction rates by half by 2030. You have to measure the rate to see if you're bending that curve.
Okay, so policy's helping slow the rate, but something is clearly still pushing the total number of invasions up. What did the study find were the main drivers still at play?
Oh, the data was incredibly clear on this. Across all three models, total, recent, and rate change, trade. Specifically, the value of imports between pairs of countries. It was significantly positively linked to the number of directional EAS every single time. So commercial trade is basically the superhighway for invasions, constantly introducing new species, maybe even accelerating the process compared to historical patterns. And the other huge factor, history itself. In that rate change model, the strongest predictor of new invasions was actually the number of invasions a country already had before 1995. It suggests this sort of self-reinforcing cycle. Places that were vulnerable in the past, maybe due to trade routes or specific habitats, just continue to be at higher risk. Legacy is a powerful force here.
That makes intuitive sense. Past performance predicts future results, even in ecology. Did they find anything surprising about, say, geography?
Yeah, a couple of interesting points there. Climatic similarity mattered. In the total invasions model, countries with more similar climates tended to share more alien species. Makes sense, easier for a species to establish if the climate feels like home. But what was maybe a bit counterintuitive was country size. In the total and recent models, smaller countries often had more directional EAS arrivals. Think Belgium, the Netherlands, Czechia, Austria. The likely reason: they're often centrally located in Europe, acting like hubs or crossroads for trade and movement, getting influxes from many neighbors.
Right, smack in the middle of everything. Okay, let's dig into the policy types a bit more. That total management score covered prevention, early warning, control. Did one strategy seem more effective than others in that successful rate change model?
You know, interestingly, not specifically within the rate change model itself. The overall score mattered, but breaking it down further didn't reveal a silver bullet in that model. But there was a weird finding in the total invasions model, the one looking at the whole history. Countries that scored higher on prevention policies actually tended to report more total EAS.
Wait, what? More prevention equals more invasions. That sounds completely backwards.
It does. But the authors have a likely explanation, and it comes back to timing and reaction. They think it's probably a reactive relationship. The countries that historically had the biggest invasion problems were the ones most likely to say, oh, we need to do something, and adopt stronger preventive policies earlier on. So the high invasion numbers came first, prompting the prevention efforts later. It wasn't that prevention failed, it was a response to an existing crisis. It just highlights again how important it is to think about the time lags involved. Problems often trigger the policies designed to fix them.
That makes sense. It's a response, not necessarily a cause. So this study shows policy can work on the rate, which is huge. But what limitations did the authors themselves point out? What couldn't they capture?
They were upfront about several things. First, their ability to detect that policy effect seemed to weaken a bit after the year 2000. They suggest this might be down to reporting lags. It just takes time for a newly established species to be found, confirmed, and officially recorded. This kind of shrinks the effective time window for analyzing the most recent years. They also mentioned a big challenge is not having super precise data on exactly when each specific policy element was implemented and what its immediate, on-the-ground impact was. That introduces some fuzziness. And finally, a persistent issue in ecology, sampling effort. It's still patchy. If we're not looking everywhere consistently for all types of species, it limits how robust our models can be now and in the future.
Okay, so pulling it all together, what's the big takeaway here?
Yeah.
Policies are bending the curve, which is good news, but history and trade are still massive forces pushing invasions forward.
Exactly. It tells us that things like the EU's big IAS regulation are definitely steps in the right direction. We need that unified approach. But, crucially, because that historical legacy is such a strong predictor of future risk, we need to get smarter about management, strengthening it, and tailoring it to deal with the ghosts of invasions past, not just the new arrivals. And we really have to tackle the trade pathways more proactively.
It sounds like future research needs to move beyond just finding correlations, like policy score versus invasion rate, and get more into the nitty-gritty mechanism.
Precisely. The authors really call for that a more mechanistic approach, like explicitly modeling propagule pressure over time, that constant stream of potential invaders arriving via trade and travel, and looking at things across different scales, properly linking specific policy actions to outcomes while remembering those time lags are real.
So for you, the learner, here's something to think about. We've heard that historical invasions are the best predictor of future ones, and current policies are helping slow the rate, but not really reversing the total pileup caused by history and trade. So what kind of policies could we even imagine beyond just trying to stop things at the border or controlling what's already here that could actually neutralize that historical vulnerability? How do you effectively legislate against the echoes of the past, especially when global trade keeps accelerating? That's definitely something to mull over.